All right, welcome. In this video, we're going to be going over the basics of fractions, just what the ideas of fractions are, some of the terminology, and a little bit of how you work with fractions. So let's get started. Keep in mind as you work through the course as a whole, that one of the advantages of video is that you can always start and stop the videos. If you didn't catch something, you can rewind and watch it again. If I get to talking too quickly or too slowly, you can slow down or speed up the video to your heart's content. Okay, so make sure to take advantage of those advantages the video has over watching a live lecture. Okay, so let's go ahead and get started. So this video and in this course, we're going to be talking about fractions. And one thing that you will notice is that fractions are also sometimes called rational numbers. And so what's the story there? Well, if you look at the first 5 letters of the word rational, that spells out the word ratio, and you may have seen ratios written before, like the ratio of 3 to 2. You may have seen that written as a fraction before, 3 and then the slash and then 2. So that's kind of the connection. There's more to it than that. That is not really needed for our purposes. For our what's enough for us is basically to more or less consider fractions and rational numbers as being the same. And so throughout this course, I'm going to be referring to fractions just because it's more the everyday language than talking about rational numbers. So for our purposes, you could treat rational numbers and fractions as being the same. Okay, so what is a fraction about? Next. Fractions give us a way of representing less than one whole of something. And of course, everybody's good at counting on your fingers or otherwise, how many rooms there are in your house, how many hours you worked last week, how many pets you have, are all values that you can count using whole numbers. But if we want to express the idea of having less than one of something, then we have to have a way of doing that. And there's basically 2 ways of doing that. You can use either decimals or fractions. Decimals are based on divisions by 10, and that's for another time. We're here to learn about fractions, which is another way of working with values less than one whole. And so how can that work, or what will be an example of where that would be needed? Well, let's say that you have a candy bar, and you're going to share it with 2 other people. And of course, you want some for yourself too. And what's fair, we will always consider what's fair, and that is that everybody should have an equal amount of the candy. You're not going to have more because it's yours. Okay, so everybody is going to share the candy equally. And so how can that happen? There's only 1 candy bar and 3 of you. So if you think about how this would play out in real life, common sense, we would take the candy bar, divide it into 3 parts, all the same size, and then each person would get 1. All right, so that's an example of where we would need less than 1 of something. How that's done, we need to know 2 values, right? You need to know how many pieces the candy bar is cut into. In this case, it was 3, and each person is going to get 1. So that is the 1 out of 3, or 1/3 that you're going to recognize. More on the terminology involved in that in just a moment. Meanwhile, another example. Let's say now you have a bowl of fruit that consists of 7 apples, and there are 4 green and 3 red. If we wanted to know how much of the bowl is red apples, well, there are 3 red apples out of the total of 7 apples. The number underneath represents the whole, or how many pieces the whole was divided into, and then the top number is representing the part that we're considering for the specific value. Okay, take a moment to think about what fraction would be used to represent the part that is red apples. We just did red apples. That was 3 out of 7. Green rather, would be 4 out of 7. 4 7ths are green, whereas 3 7ths were red. All right, so a little bit of terminology to come next. When you write a fraction, the top number is the numerator, the bottom number is the denominator, and the bar in between is called the fraction bar. A way to remember that, the way that I remembered it back when I had to try to remember this stuff, is that I remembered that denominator and down both start with the D, so that's how I remembered it. So if you had the fraction 5/8, that would imply that we had one whole divided into 8 parts, and 8 is the denominator, 5 is the numerator. Our particular value is 5 out of those 8 pieces. Also, you may see a fraction written vertically as we did first, or you may see it with kind of a slanted fraction bar. If that's the case, those two values are the same. We just write them in two different ways. Okay. If you are typing or texting somebody a fraction, it's going to be a lot easier to just use the slash on your keyboard to write it in the second way. A lot of times in books, you'll see it written more in the first way, that is vertically. But it's important to know that these represent the same value. So as other examples, 3/7 and 3/7 are written like that are the same. We can have fractions that are negative. Negative 2/5 is an example of a negative fraction. By the way, with negative fractions, there's a variety of places we can put the negative sign. You may see it in front of the numerator, as I've done here, that is in front of the 2. You could see it in front of the entire fraction, that's negative 2/5. And then technically you can see it in front of the bottom number, the denominator as well. But we usually try to stay away from that. The more advanced you go in math, the less you're going to see that at the bottom. But there, it has its uses. It's just more commonly in front of the numerator or in front of the whole fraction. Okay, all right, so that's good for now. All right, so I wanted to show you this next picture as just kind of a fun example. You may have already seen this online someplace before, but in the picture it says in the 1980s, A&W, which is a burger chain that you may or may not have ever seen before. There's not very many of them anymore. But in the 1980s, A&W tried to compete with McDonald's by selling a McDonald's quarter pounder by selling a 1/3 pound burger for cheaper. And as it turns out, A&W's burger didn't do so well because people thought that a 1/3 pound burger was smaller than a 1/4 pound burger. And so that's kind of funny and is relevant for us. And what makes it funny, of course, is that as we know with a whole number, of course, 3 is less than 4. That's true. But if you think about it, if you have one burger, let me draw 2 burgers. If you have a burger and it's divided into 3 pieces versus dividing it into 4 pieces, then dividing it into 3 pieces is going to give you bigger pieces. And so that's the thing. Keeping the fixed numerator, that was the top number, and making a bigger denominator, it's going to give you smaller pieces. And if you think about it, that should be common sense. If you order a pizza for yourself and maybe a couple of people at your house, then you know how much pizza you're getting. But then let's say 3 more friends drop by, and of course you have to share with the people who just dropped by. Of course, everybody's getting less pizza, right? So the bigger the denominator is, the smaller the fraction will be. All right. So moving on. All right, so here's a couple more examples. In each case, we want to write a fraction to represent the shaded part of each drawing. So at this point, pause the video and try to do each of these yourself, and then restart the video and then see how you did. Okay, so now let's try each of these. For the first one with the rectangle with the purple shading, the whole is divided into 1, 2, 3, 4, 5 parts. And out of those 5 parts, 3 are shaded. So that is 3/5. Okay, for the circle, the second one, it's 1, 2, 3, 4, 5, 6, 7 slices. You'll notice that I put little ticks there just so that I could count and not accidentally miss one. It's divided into 7 parts. And there are 1, 2, 3, 4 that are shaded. So that is 4/7. Okay, drawing these fractions as a rectangle versus circle, or this triangle one that we've got last, there's no real reason for doing one versus the other. I think the rectangle ones are easier to draw. A lot of times when you see fraction stuff, you'll see it done with circles because a lot of times we tell you stories about pizzas and pies and things which are round most of the time. So that's why you see the circles. However, the rectangles are easier to draw. Conceptually, there's no real difference though. Okay, in the triangles here, we've got 1, 2, 3, 4, 5, 6 pieces. There are a total of 6 pieces, out of which 1, 2, or 3 are shaded. So that's 3/6. Okay, by the way, if you look at that and say, okay, well, that reduces to 1/2, you're right, and we'll get there. But for now, we're going to leave that as 3/6 because we're just getting used to the ideas of fractions as a whole. There are a couple of things that can make working with fractions kind of tricky, and so we want to go over those things next. Before we do that, I did want to mention that you can do this. You can definitely do fractions if you can follow directions, if you can color your hair, or if you can change the air filter in your car, or if you can make a package of chocolate chip cookies from the refrigerator section at your grocery store. If you can follow directions like that, then you can do fractions, because really a lot of it is step by step. There are a couple of things that can make working with fractions trickier or more tricky than working with just counting numbers. So let's go over some of these things. Being aware of them will make this a little easier for you. Okay, one big thing is that as we've seen, for fractions, it takes 2 numbers to represent one value. For example, in part A here, it says Joe wrote 3 pages of his paper. Is that a lot? Well, he wrote 3 pages, depending on your opinion about writing, that could seem like a lot or not. But the bigger issue is we need to know how big his paper is. If he's supposed to write a 4-page paper, then he's almost done. If it was a 3-page paper, he is done. But if it's supposed to be a 20-page research paper, he's barely gotten started, right? So yeah, 3 pages out of what, right? So you need to know how many total pages there are in order to make a decision about whether that's a lot or not. Okay, for B, Kelly cut her cake into 12 pieces and ate some of them. Is that a lot? Well, of course, you'd need to know how big the cake was, I suppose, but let's say that it's just your regular birthday cake size cake, okay? And we cut it into 12 pieces. If she ate some of them, okay, sure. Is some like 1 piece, 2 pieces, 3 pieces, or is it like 11 pieces? Okay, so you need to know how many pieces we're talking about in addition to knowing size, how many parts the whole was cut into, which was the 12. Okay, another issue is a value can be represented in a variety of ways. If you have a whole and is divided into 4 parts, and we're going to shade 2 of them. Okay, there's one whole, and we've divided it into 4 parts, and we're shading 2 of them. That's 2 out of 4. If we take and have the same size whole and divide it instead into 2 parts and shade 1 of them, then that represents the same amount, right? So there's a variety of ways, many ways of representing one value, unlike like 3, okay, you've got 3 kids, which is just 3. I guess if you want to play around, you could say 2 plus 1, but 3 is just 3. With fractions, there's a lot of ways of representing them: 2/4, 1/2, 3/6, 11 22nds, right? If you don't get that, we'll get to that, and that's fine. The point is, you can represent a value in many different ways, and as it'll turn out, as you'll see, some of the common mistakes people make are in changing from one version or format of the number to another format. Okay, so we want to keep that in mind. You can represent a number in a lot of different ways. When you're working with fractions, the whole needs to be cut into parts of equal size. Okay, if you have, again, we'll stick with a cake or a candy bar. Let's go with a cake. If we're going to take a cake and cut it up into 6 pieces, and you're going to eat 1 piece, then you want to have a sense of how big that is, right? But if I take and cut it into, like, there's a piece and there's a piece, 1, 2, 3, 4, 1, 2, 3, 4, 1, 2, 3, 4, 5, 1 more. There's 6 pieces. 1, 2, 3, 4, 5. 6. There's 6 pieces, okay? If you cut your pizza or your cake like this and say, okay, well, I would like to have 1 piece, or I had 1 piece, if that was the piece you had, then you had a lot more cake than if that was your piece, right? If you have kids and you try to give one of them this piece and the other one that piece, of course, you're in for a fight, right? So you have to cut your parts equally. Otherwise, there's no way to answer questions involving fractions if the whole is cut into parts of all different sizes. So always in our work, the whole is going to be cut into parts of equal size. Speaking of which, you do have to know what the whole is. Okay, as an example, suppose that Jen cut her pie into 6 pieces. She went out to the store, bought a pie, or better yet, made one, and she cut it into 6 pieces. And then she ate 2, and then she put the rest into the refrigerator. Then Beth, her roommate, came home and ate half. We want to know how much is left. Okay, so let's think about that for a minute. So let me draw Jen's pie. It's kind of not a great looking pie, but that's okay. She cut it into 6 pieces. So then she ate 2. Let's say Jen had those 2. So there are 4 pieces left. They go into the fridge. So Beth came home and ate half. That half, is that half of the pie, or is it half of what's left? Okay. If Beth comes home, Jen says, oh, there's pie in the refrigerator. Save me some. And then Beth says, okay, well, I'm going to have some, but I'll save her some. And she eats half of what's left, then that's different than eating half of the pie. If Beth eats half of what's left, then that's 2 pieces of the original pie. But if Beth eats half, then that's 3 pieces. Okay, so again, we have to know what our whole is, or what our whole is, so that we know what the half is. In this case, when we're referring to the half, is that half of the original pie, or is it half of what's left? Okay, so again, the point here is we need to know what the whole is. In this question, I could never put this question on a test as written because you have no way of answering that. Okay. All right. All right, so moving on, we'll frequently encounter fractions when measuring things. So let's take a look at that. Here, I've blown up a picture of a little piece of ruler. Let's say that this is done in inches. Rulers are most frequently divided up by 2s. So first, a 1 inch would be divided into 2 equal parts. So on half of an inch, and then each half is divided into 2 parts. So that gives us 1/4 inch. 1/4 inch is divided into 2 parts, each of which would then be 1/8 of an inch. Okay, so and then further subdivisions will give us shorter lines. So you can see here that the 1 inch line is the longest. The half-inch line is shorter, but longer than the 1/4 inch line. And then the 1/8 inch line is even shorter. And then beyond that, we have 16. And then depending on what ruler you have, it may go 30 seconds or 64ths and so on, but all based on divisions by 2. So let's see if we can use this to answer this question. We're supposed to know how long is the yellow bar for this. Okay, so it looks like it starts at 0, as it should, and then it ends at, well, let's see, the 3/8 mark. So it's 3/8 of an inch long. Okay, and that's the end of that. If you're unfamiliar with how rulers work, you should spend some time practicing working with them and getting used to reading off what the markings are. Okay, here's another example. In this case, we have a red bar and then a piece of ruler. This time we have more than one. It goes all the way up beyond 6. So let's make that a little bigger. So we want to see where the red bar ends. So it looks like it ends right there. So we need to figure out where that is. So you should pause the video and see if you can figure out where that will be. Okay, so do that. All right, so then you're back with this. So the longest lines are the whole numbers of inches. So then right here, we should be at halves. So that's 6 1/2. And then halfway between 1/2 and 7, this should be the 3/4 mark. So what's going on here is, let me just focus on that part. In between 6 and 7, we have that first of all divided into halves. And then beyond that halves, it's divided into quarters. Okay, so this is the 3/4 mark. Okay, and then the next step down from that is going to be eighths. Right today. So this is going to be eighths. All right, so let me take and divide our whole inch into eighths. So there should be 8 parts. And then this is halfway between the half and this eighth. So half of an eighth is a 16th. So let me put in one more set of divisions. This is kind of relaxing, isn't it? Nice. All right, so there we are. So we need to figure out where exactly we are. We're past the halfway point. This was 6 1/2. And then we were before the 3/4 mark, which would be halfway between 6 1/2 and 7. So this is 6 3/4. And then in between 1/2 and 3/4, we'll have eighths. So this is probably easier on you to do it in terms of sixteenths. So let's just count the number of sixteenths we have. The reason I hesitated there is because I need to go to talk about how to change 6 1/2 into 6 4/8 and 8/16, and we haven't gotten there yet. So at this point, what's easier is just to count sixteenths. So there's 1, 2, 3, 4, 5, 6, 7, 8, 9, 9 sixteenths. So overall, our value is 6 9/16. Okay, how to do that more easily so that you're not counting every single tick mark, that is going to come in a little while. Also, in our class, we're not going to be working with this type of value so much. This thing is called a mixed number because it is a mix between a whole number, this 6, and then this actual proper fraction, which is 9/16. So we'll deal with mixed numbers at a later date. Okay, so again, if you're at all unfamiliar with working with rulers, you want to spend some time practicing with that. All right, one other example. Here we've got a blown up image of a syringe. The units on this would have been cc's or cubic centimeters, but we don't need to know about that. I just want to take a look at this and for you to think about how many divisions there are between the 1 and the 2. And so what would the corresponding fractions be? What is one little tick mark worth in here? Okay, so you have to think about, well, how many parts is the whole divided into? So let's make that bigger still. So there's 1, 2, 3, 4, 5 pieces. So each of those tick marks is worth 1/5 of a cc. Okay, what's a cc? We'll leave that for another time when we talk about units and metric system and stuff like that. But it's 1/5 of a whole unit. Okay, all right. So this brings up one other thing before we move along, and that is when you are counting this or even the images with the rulers, you want to make sure that you're counting the spaces in between and not the lines themselves. So I want to make sure that you're not saying that this was 1, 2, 3, 4, because there are 4 lines in there. Okay, to make that plainer, let's say that we have one whole and it's divided into 4 parts. Okay, one whole divided into 4 parts, you have to make 3 divisions. Okay, that's 1, 2, 3, 4. If you think about it, the number of pieces you get is going to be bigger than the number of cuts that you make. So if you have one cake and you cut it once, you get 2 pieces. If you cut it 2 times, you have 3 pieces. If you cut it 3 times, you'll have 4 pieces. So when you count, you have to make sure and count the number of spaces taken up, and not the number of lines. So here, how long is this yellow bar? Is it 2 or is it 3? Well, you count the spaces between. There's 1, 2, not 1, 2, 3. You count the spaces between, not the lines. Here's another example. Let's say that you are going to watch a movie and you're going to watch it from 9 p.m. to midnight. Okay, how long is the movie? Okay, well, from 9 to 10 is 1 hour. And then from 10 to 11 is another hour. And then from 11 to 12 is the third hour, so it's 3 hours. Okay, but if you think about it, 9, 10, 11, 12, that's 4. But of course, that's not 4 hours. But to count from 9 to 12, 9, 10, 11, 12 is 4. But again, you have to count the spaces between, which is 3. Okay, moving on. A little more terminology, proper versus improper fractions. So a lot of math terms have an everyday meaning, and then there's a specific math meaning to this, and proper versus improper is one. So on a proper fraction, the numerator is less than the denominator. Examples will be 3/4, 5/8, -7/12. Those are all examples of proper fractions. The numerator is smaller than the denominator. Improper fractions have the property that the numerator is greater than or equal to the denominator. So examples would be 5/2, 11 or 13/5, -7/3, 4, right? Because you could always write 4 as 4/1. Any whole number can be viewed as a fraction, and when it is, it ends up being an improper fraction. In the improper fraction, the numerator is greater than or equal to the denominator. The word improper here, like I said, there's a math meaning and then an everyday meaning. The word improper sounds negative. It sounds like there's something wrong with the fraction. Oh, he was acting improperly. Okay, whatever. That sounds bad, right? But for fractions, proper versus improper, that's just the name. There's plenty of situations in math where it's more convenient to work with the fraction when it is in an improper form versus changed to some other form. Okay, so try not to make a value judgment between proper versus improper. It's just the name of the fraction. Okay, all right. It turns out that improper fractions are found whenever we have more than one whole of something. Okay, so as an example, here we've got these 5 rectangles, out of which 4 are completely shaded and 1 is not fully shaded. We want to write this quantity as an improper fraction. So taking a look at the picture, it looks like one whole. Here I've gone ahead and said it. One whole is a set of 3 little squares. So each whole is divided into 3 parts. So then it sounds like this problem is about thirds. So if this problem is about thirds, then we should see how many thirds there are. There's 3, 6, 9, 12, 13, 14, 14 of those thirds. Okay, so this, of course, brings up the question, well, if the whole is divided into a certain number of pieces, how can you have more than one whole of something? Like going back to the candy bar example we had, okay, if you had a candy bar divided up into 3 pieces, how could you have 5 of those pieces? It doesn't make any sense because you only had one candy bar divided into 3 pieces. The confusion there comes in because we can have more than one whole of something because, as we saw, what we can consider to be the whole can depend. Here, what I'm considering to be the whole is one block of 3. If we take all of these, the entire picture to be the whole, then it's divided into 15 pieces, out of which 13 are shaded. Okay, so which is it, 14 thirds or 13 fifteenths, which are, of course, two different numbers? Well, it depends on what you're considering to be the whole. The value here, shaded in blue, is 14 thirds, where one whole is divided into three parts. If the entire set of 15 little squares is our whole, and I've got 13 of them shaded, then what's shaded in blue here is 13 fifteenths. Again, remember we've gone over those few things that can make fractions confusing, and this was one of them. You have to keep straight what your whole is. Is the whole amount this block of 3, or is it all of them? Which is it? So usually it's the context that makes this clear. So we'll see an example of that here in a moment. Okay, I did make a kind of a little mention of mixed numbers earlier. Here's more of it. A mixed number contains a whole number and a proper fraction. So if you looked at this and said, okay, well, it's 4 2/3, then yeah, you're right. But this course, this sequence of videos is not going to go over mixed numbers at all. We'll deal with that later, some other time. So for our class, we'll only be dealing with proper and improper fractions, not with mixed numbers. Okay, so to go back to this confusion between, or potential confusion between the 14 thirds and 13 fifteenths just for a moment. Let's say for a party you ordered some pizzas, and these are going to be vegan pizzas or something, they're green. After the party, let's say this is what's left, okay? You ordered 2 of these pizzas, and each pizza was cut into 6 pieces, and one of the pieces, the white part has been eaten, okay? The green part is still there. One of the pizzas had 5 pieces eaten, and then the other one was completely untouched. Okay, if you want to express how much pizza is left, then there's several ways of thinking about it. If each pizza is divided into 6 parts, then there are 7 of those slices left. Okay, so 7/6 of one pizza. Okay, here I'm considering one whole to be one pizza. Okay, we've got a pizza, it's divided into 6 slices. There are 7 of those slices, so we have 7/6 of a pizza. On the other hand, we could say, okay, well, out of what you ordered, how much is left of all the pizza? Okay, that makes the whole different. Okay, the whole was both pizzas, not just the one. How many slices of pizza did you end up buying? Well, you have 2 pizzas, each of which is in 6 parts, and so 12 slices. Out of those 12 slices, there are 7 left. Okay, of course, 7/6 is not the same as 7/12. It does represent the same amount of pizza overall, but the 2 values are different because we're saying 2 different things. In the first case, 7/6, the whole was one pizza, and there are 7 of those parts. The whole amount of pizza that you purchased was 12 slices, out of which there are 7 left. Okay, so hopefully that makes that a little bit clearer. It is going to be something that we'll have to always be careful of, what we consider the whole to be. Okay, all right, moving along. We can consider fractions on a number line, just like you might consider whole numbers on a number line. Here, this is a graphic basically just to take a look at. We have a whole divided into halves, then thirds, then quarters, sixths, and eighths. This basically is just going to serve as a reference for you. Again, one thing to note is that 1/4 is smaller than a third. Okay, going back to that hamburger example we saw. Okay. All right, so a couple of more examples. Let's say we want to graph 3/5 on the number line, and then also 8/3 on the number line. So pause the video, try at least the first one, and then we'll go over it together. All right, so now I want to graph 3/5 on the number line, and so far it's blank, so we have a lot of freedom on how we can draw this in. I'm going to make just 3/5 is less than 1, so I'll mark like 0 to 1 right here, and then we need fifths, okay? So if I need something in fifths, then I'm going to need to make 4 lines in between. and I want to make them equally spaced. And this can be a little bit tricky, but we'll just do our best. 1, 2, 3, 4. Okay, so out of those 1, 2, 3, 4, 5 pieces, again, I drew 4 lines to make 5 pieces. Out of those 5 pieces, I need to shade 3 of them. So 1, 2, 3. There's 3/5 on the number line. Okay, for 8/3, I know that 1 has 3/3 in it. So 0 to 1 will have 3/3, and then 1 to 2 will have another 3/3. That gives us 6, and 2 to 3 will have another 3/3. So in all, we'll have 9/3 there. So I need to go all the way out to 3 if we're going to represent 8/3. Okay, so now each of these whole units is going to be divided up into thirds. So there's 1, 2, 3 wholes divided up into thirds, and we want 8 of those thirds. So there's 3, 6, 7, 8 thirds. Okay. All right, we're almost done. Okay, so just one more slide left. A couple of properties of fractions involving 0 and 1. Before we get into it, I did want to mention when you see properties in math, that basically just means kind of rules that whatever you're talking about, whatever numbers you're talking about, can go by. Like if you're in a geology class, you might talk about the properties of different rocks, that is, its nature or characteristics. In math, what a property is kind of a nature or characteristic of the number you're dealing with, and how does it behave and what kinds of things you can do with it. So properties and rules, you can almost interchange those two terms. So what are some facts about fractions when you're dealing with zeros and ones? Okay, so n divided by 1 is equal to n. Here, if you're less familiar with using a letter to stand for a number, you'll get more familiar with it. But basically, we're just using a letter in place of a number. If you like, if it makes you more comfortable, put a specific value in here. 5 divided by 1 will equal 5. Okay, and this should be kind of common sense, hopefully. If you have 5 of something and you leave each of them whole, that is, each one is divided in one piece, then you're going to still have 5 pieces. Okay, division, a number by itself is going to equal 1. If you have 5 of something and you divide those 5 into 5 equal parts, then you're going to get 1. A way of thinking about this is to remember that division kind of involves sharing things equally if we're making into parts of equal size. So pretend that you have a certain number of cookies to divide up among a certain number of children. So let's say that you have 5 cookies. Okay, if you have 5 cookies and you have 1 child, 5 cookies to divide up among 1 child, then that 1 child is going to get 5 cookies. Okay, that should make sense. If you have 5 cookies to share among 5 kids, okay, then each kid is going to get 1 cookie. Okay, so that should make sense. Any number divided by 1 will give that number itself. Any number divided by itself, except for 0, as we'll see, is going to equal 1. Okay, if you have, let's skip over the top one for a second because it's trickier. If you have no cookies and you need to share them among 5 kids, then each kid is getting no cookies. That should make sense. Any number divided by 0 divided by any number that is non-zero is going to give you 0 for an answer. Again, if you have no cookies to split among 5 kids, then each kid gets no cookies. Last of all, if you have 5 cookies and no kids, how many cookies does each non-existent kid get? Okay, well, that's kind of a trick question, right? How do you answer such a question? How do you give a cookie to a non-existent kid? Well, you can't, or you eat them all yourself, or how does that happen? There's no place to put these cookies if there's no kids there to eat them. So let that kind of help you remember that any number divided by 0 is undefined. Okay, all right, so these 6 things, and then we're done. We will just want to simplify each of these. Here, 9 divided by 9 is going to equal 1. Negative 6 divided by negative 6 is going to equal 1. 0 divided by negative 1, there's a 0 in there. Take a second to decide if that should be 0 or undefined. Okay, the 0 is on top, so that makes it 0. 5 divided by 1 is going to be 5. 13 divided by 0 is undefined. Negative 13 divided by 1 is going to be. All right, that takes us to the end of this first part. If you have any questions on it, let me know. In the next part, we're going to work on how to change fractions to different forms. How do you turn 1/2 into 3/6 and back again, as well as some other interesting and fun things. Okay, so in the meantime, let me know if you have any questions, and then have a great day.